All right, so in order for an OR inequality to be correct, you're going to end up having greater than the bigger number of your two answers and less than the smaller number. So if you don't end up with that, you've done it wrong. Also, your OR inequalities point in opposite directions. So let's take a look at 17. Already got a head start on it. We're going to undo subtraction with addition. So we've got n greater than or equal to 10, or undo division. It's n divided by 9 less than 0. So we're going to multiply by 9 on both sides. So that gives us n is less than 0. So we're going to make greater than or equal to 10 and less than 0. Perfect. Over here, they're both additions. So we're going to undo addition. Make sure we subtract the 4 and the 1, not the 11 or the 2, because we're trying to get m by itself. So if we subtract 4, we get 0, and now m is by itself. As desired, m is greater than 7. We subtract 1 on both sides, m is less than or equal to 1. Okay? Undo addition with subtraction, undo multiplication with division, undo division with multiplication, undo subtraction with addition, undo addition with subtraction. All right, now I definitely covered them all. Anyway, or greater than 7, less than or equal to 1. All right, absolute value. If ever you feel negative, just remember your absolute value. So we talked about how we have these steps. Isolate the absolute value. That means get the absolute value symbols by itself. If you've got the absolute value of a plus 1 equals 2, absolute value is by itself. Move on to step 2. Determine whether the absolute value is possible. It's possible if it's 0 or positive. Then we set up two equations. A plus 1 equals 2. A plus 1. Oh, great, my lovely timer is back. A plus 1 equals negative 2. When absolute value would not be by itself, this would be 2 times. That was a big thing on the quiz. It's 2 times the absolute value. So we're going to undo that multiplication with division. If it's addition, it's going to have an addition sign. If it's subtraction, it's going to have a subtraction sign. Subtraction signs go between the two things that are being subtracted. Okay? Step 4 is to solve both and then give a final answer. So let's look at some of these absolute value problems. Absolute value is already by itself. It is possible. Set up two equations. V equals 10. V equals negative 10. Solve. Well, it's already solved, so we're done. Yay us. Step 1, absolute value by itself. There are no operations occurring outside of the absolute value. All of the operations are inside absolute value symbols. Step 2, is it possible? Yes, it's possible because it's positive or 0. Non-negative. We cannot take the absolute value of something and get a negative answer. Set up two equations, one with the positive, one with the negative. Whatever's inside absolute value always is going to stay the same. The only thing that's changing is this number here. We need a positive and we need a negative. Undo addition with subtraction. Undo addition with subtraction. K equals 4 and K equals negative 14. Alrighty, that's that one. Number 21. Absolute value by itself, check. Is it possible? Check. two equations. One with the positive, one with the negative. You need to run through the steps every time. You need to know the steps. They're not going to be written on the board for you. You need to know what those 4 steps are. It's a quick check, 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 check. If you know the steps, you should be good to go. You need to know that step 1 is absolute value by itself. Subtract 4. 8x equals 48. Divide by 8. And x equals 6. Subtract 4. 8x, that's supposed to be a 4. It's not always super responsive for some reason. Equals negative 56. Divide by 8. X equals negative 7. So I have 2 answers for all absolute value problems. Only for absolute value problems or compound inequalities would I want to have 2 answers. Looking at 22. Absolute value by itself? No, not yet. What operation is occurring to the absolute value symbols? There is no addition sign. There is no subtraction sign. There's no division sign. What's left? Oh yeah, Mr. Course said that when something is written directly next to something with no other operation symbol, it's multiplication. Undo multiplication with division. Absolute value of x is equal to 10. Is it possible? Certainly. Set up 2 equations. X equals 10. X equals negative 10. Solve. Check. We are done. We are ready to go. Next problem. How many we got left? 4 more on this page. Step 1. Absolute value by itself. No, it is not. Undo the addition happening outside the absolute value first. I cannot set up 2 equations before absolute value is by itself. If you make it 13 and negative 13 for this problem, you are going to get it wrong. Absolute value of negative 3 plus r equals 5. Absolute values by itself. Now we can set up 2 equations. 5, negative 5. Okay, we're going to undo minus 3 with plus 3 on both sides of the equal sign. Whatever you do on one side of the equation, you have to do on the other side of the equation. Do not do something on the same side unless you're combining like terms. Add 3. I need an equal sign in there somewhere. I swear I tried to write an equal sign. R equals negative 2. Okay, 3 more. Step 1, absolute value by itself. Nope. Subtract 10 on both sides. Negative 1 minus 2v equals negative 25. Step 2, is it possible? Heck no. We're done. No solution. It is not possible to take the absolute value of something and end up with a negative number. You can only make that decision once absolute value is by itself. If we ended up like dividing by a negative, that would make the 15 positive, and we would just keep solving. Alrighty. It's time for everybody's favorite time of the day. The less than great or. Okay, so if you have less than or equal to, use an and inequality. That looks like this. If you have greater than or equal to, use an or inequality. That looks like this. Okay. Similar steps. Step 1, absolute value by itself, check. Step 2, two inequalities. N greater than or equal to 8. It's great or. N less than or equal to. Inequality has to switch, and you make it negative. Solve. Nothing to solve. Less than or equal to 8 goes this way. Greater than or equal to 8 goes this way. Cool. Last one for the page. Absolute value by itself, yes. Is it? Technically, we should check to see if it's possible. All the inequalities are going to be possible. K over 10 greater than 2. K over 10 less than negative 2. Multiply by 10 on both sides. K is greater than 20. Multiply by 10 on both sides. K is less than negative 20. It's going to be greater than, and it's an or, great or. So we want to be greater than 20, less than negative 20. If your answer doesn't fit on the graph, it's probably, no, it's not probably wrong. It is wrong. All right. End of page